Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze the soda can for its modal analysis. We will start by double clicking on the modal module. First, we'll go to engineering data and double click. Here, I will choose engineering data sources, general materials. Aluminium alloy, or rather aluminium is the material which is used for making of the soda cans. So I'm choosing aluminium alloy from here. I'll go to project and update project. Next I'll right click on geometry and I'm going to import the geometry, the model. Then I'll go to the option of model and double click. First we'll go to geometry and click on the plus sign here. This is the top portion of the soda can. I'll change this material to aluminum alloy. Also I'll change the material of the body to aluminum alloy. Then I'll go to mesh and I'll generate the default size of the mesh. Now we'll go to the option of model. Here I'll right click and insert fix support. At the bottom end of the can, I'll select all these surfaces. I'll click on apply. Next I'll go to solution and right click and solve. Now here you can see the first three values of frequency are 0, which means this is a case of rigid body for the first three modes. Then we have the last three modes frequency available. So we will click here, right click, select all, right click, create mode shape results. I'll go to solution and solve. Now we'll click on total deformation 1. You can click here and see that only the top portion is getting animated. The deformation is too high, 1175.4 mm. So this is the first one. Then we'll go for the second one. Here you can see the deformation is 1150.5 mm, which is again a very high value. You can animate and see the pattern has changed a bit. Then we'll go for the third one, 1250 mm, and you can also check the pattern of its motion. Then we'll go for the fourth one, for which a frequency is available, which is again very small, 2.05 to 10 raised to minus 2 Hertz. Deformation is very high, 1070.3 mm. Then we'll go for the fifth one, 1134.6 mm, for a frequency of 3.6779 into 10 raised to minus 2 Hertz. You can animate and check its pattern of motion. And this is for the last one. Here you can see the deformation is completely 0 and only the cap portion is moving. So the deformation is 1248.7 mm for a frequency of 6.597 into 10 raised to minus 2 Hertz. Now you got 6 modes of frequencies because if you click on analysis settings, the max modes to find are 6. Now suppose if you want to animate this body of the can, what you can do is you can just hide this body for some time and you can check out the frequencies, or rather I would just suppress this body such that we'll be solving once again. When you click on hide, it means you are not taking it into consideration for solving further. When you click on suppress, it means the body does not exist and this only one part is existing. So that's why now only for this body you have got these values of frequency, which is very high. So you can very clearly see that when you consider the cap or the top portion, whatever you call it, the lid, when you consider that, obviously the value of frequency was very low. and at that value you were getting those frequencies and this body was acting completely rigid. But now that the lid is gone, what you have is only the body. So for this body, this value of modal frequency is extremely high. You can see it is 1367.2 Hertz starting value. So we'll click on deformation and we can see it is 725.53 mm. Now you can see for this body itself what is the modal frequency and its deformation. Also you can see its pattern of motion if the lid does not exist. So let's talk about the second one. We will again animate and see. Deformation is 727.89 mm for a frequency of 1420.1 Hertz. You can read it from here or from here as well. Then we'll go for the third one. Deformation has reduced 407.9 mm for a frequency of 1812.3 Hertz. And you can see its pattern of motion. Now this value of frequency is too high. When you do the modal analysis, you basically want to mean that these are the frequencies which should not be tapped so that your body is safe. So if these deformations are not to be encountered, these frequencies should be completely avoided. And you can see for the fourth one, deformation is 405.4 mm for a frequency of 1815.7 Hertz. This is the fifth one. 521.36 mm maximum, the value is increased for a frequency of 3015.3 Hertz. See the pattern of motion. Every pattern is different from the other. And then comes the sixth one where the deformation is 477.35 mm for a frequency of 3074.9 Hertz. We will see its pattern of motion. It is definitely different than the rest 5. So this is how you analyze the soda can for its modal analysis. The highlight of this analysis is the separate analysis which I could do, that is of the lid initially, and then I suppressed the lid to only get the body of the can and then analyze it separately. So this analysis gives you a important part that sometimes the body will act rigid because its modal frequency is very high, and some other part of it, the same model, will have a frequency which is very low. So you have to tap them separately and get their values. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.